This is the last reaction. It's another one of my favorite reactions, ozonolysis. Notice that the first step of ozonolysis is the addition of ozone, hence the ozonolysis name. But however you do the ozonolysis, what we're going to be doing is breaking the double bond completely into two parts. We're going to oxidize it and we're going to cleave it. All right, so what I like to do to remind myself that I am cleaving it is to make a dotted line reminding me, hey, that's the double bond that I'm breaking. And it's important that we notice the second step of the reaction, because depending on the second step, that's what the product is, it's going to affect the product of the reaction. This is dimethyl sulfide. Dimethyl sulfide is a reducing agent. It takes oxygens away. And when you use dimethyl sulfide, what basically we're doing in the reaction is that we're breaking the double bond. So I'm going to break the double bond. I'm going to separate the double bond. And then I'm going to put an oxygen on each side of the double bond. Now notice that if you had hydrogens attached to your double bond, they're still going to be in place. So these two molecules, first of all, they're the same molecule. And if you have a hydrogen attached to a carbonyl, that's an aldehyde. So under reducing conditions using the dimethyl sulfide, I can get aldehydes and I also can get ketones. A ketone would actually have two carbons attached to the carbonyl. Now that's important because when you use oxidating conditions, this one is hydrogen peroxide. You normally do it under basic conditions here, so I should put base. But when you use oxidating conditions, we will not be able to isolate the aldehydes. What happens is that the aldehyde, in the presence of hydrogen peroxide, is going to get oxidized to the carboxylic acid. So instead of getting two molecules of the aldehyde, I get two molecules of carboxylic acid. I still get ketones. If you had two carbons attached to the double bond, you can still get it because we cannot oxidize a ketone. But we will not be able to isolate the aldehydes. So this is a fun reaction. Make sure you practice it with different double bonds, especially with mixtures of hydrogens and carbons directly attached to the double bond. But another fun way of asking the exact same reaction is giving you the products and asking you what was our starting material. So let's see what we did here. What we did here is that we broke the double bond in two, we pulled the double bond apart, and then we added two oxygens, one on each side. And here they're giving us the two oxygens already on there. So what we need to do is that we need to put the two double bonds back together. So connecting them again. So I'm going to take this one and I'm going to draw it here. I'm going to take off the oxygens. And I'm going to take this one right here. And I know that that double bond was connected to this double bond before the ozonolysis. So I'm going to put that double bond there. And now I'm going to connect the double bonds. Again, I'm trying to show you that to see the starting material, you put the two double bonds together. And this is a starting material that allowed me to obtain these two. By the way, this is a ketone. Notice that I have two carbons attached to the carbonyl. And I would have gotten these two products regardless of the conditions that I use here because you cannot oxidize ketones.